All right, you guys, let's work through this review. Let me try and remind you, I'm going to be working decently fast. So use the idea that this is a video. Hit pause, rewind, rewatch anything that it is that I'm going through. Again, the earlier that you work through this review, if you have questions, feel free to get in touch with me. You can log into the asynchronous time of any of my classes. You're always welcome. As long as you have questions and you're trying to improve your knowledge on the subject. So again, just trying to remember, part of this review, right triangles means it involves trig. So if we're going to be doing trig, we need to check the mode on our calculator. We don't want to be working through radians. That's going to be the default of every one of these because that's the standard unit of measurement for working with angles. But our trig that we're going to work through is with degrees. Make sure that word is highlighted, then you can clear out and your calculator's ready to help you a ton. Okay, so don't need the calculator just yet. We're simplifying radical form, which means we need to break apart 125 and see if we can find parts of 125 that we can square root. 125 is 5 times 25, and 25 is 5 times 5. Remember, focus on the prime factorization, those prime numbers that are inside of this radical. If we find a pair, we can cross off a pair. 5 times 5 is 25, and I know the square root of 25 is 5. So 5 gets to come out. I got no other pairs. 5 made it on the outside, and there's still a 5 left inside of the radical. So here is the simplified radical. Again, just to double check, you guys, on your test, you can put in the square root of 125. You got this decimal here. If I put in my answer, 5 times the square root of 5, I better get the same decimal. Otherwise, I know immediately I've done something wrong and I should recheck my work. Okay? So here, again, I prefer to make that house to realize what's inside, which is 40. And we can't forget about that 2 that's on the outside. Okay? 40 happens to be 4 times 10. I generally, if I see something I can square root, I'll go ahead and do that. But we'll go the slow route here. 4 happens to be 2 times 2. 10 happens to be 2 times 5. Here are our prime factors. I find a pair of 2s. I cross off a pair, and I take 1 outside to be with the 2 that's already there. There's no other pairs. I got a 2 and a 5 left. So whatever's on the outside, multiply those together. 2 times 2 is 4. Whatever's still left inside, I put back together. There's only a 2 and a 5. Remember, we're not focused on these things that broke down. 2 times 5 is 10. Okay? So here, find the values of the variables. Answers in simplest radical form. This leads me to think we're looking at special right triangles. So this is a 45, 45, 90 triangle. If I was going to label my sides according to the rule, this would be x, x. And even though that says x, this is actually my x times the square root of 2 side. All right, there x is more like just a question mark. So if x is 26, I just got to plug that in. And my answer would be 26 times the square root of 2. Again, 90 degrees, if these are the same, this is a 45, 45, 90 triangle. These sides, x, x, and x times the square root of 2. So here's my equation that I need to solve for x. I have x times the square root of 2 equals 12. Divide both sides by the square root of 2. And I know what x is. Problem is I cannot leave a radical in the denominator, so I need to rationalize it. This is our new skill. Multiply the top and the bottom by the square root of 2. And the top, I just have 12 times the square root of 2. And the bottom, I have the square root of 2 times the square root of 2, which is the square root of 4. Good thing is, I know what the square root of 4 is. That's just 2. I can't reduce the 2 into this radical, but I can reduce the 2 with the 12. So my answer is 6 square root of 2. That's what x is, and that's what I was looking for in this problem. So both of my answers are 6 times the square root of 2. All right, this is a 30, 60, 90 triangle. The side across from 30 is always going to be x. Maybe it'd be better if I used a different color. All this is kind of getting together. So the side they gave me, that's actually my 2x side. And this would be my x times the square root of 3 side. So I want to find out what x is. I got to take my equation where I had my matchup. 2x equals 48, solve for x. Turns out x is 24. So if I start plugging it in, that's my side. They said x. The side that says y, I need to plug 24 in there. That would be 24 times the square root of 3. 6, here's the toughest version. Label my sides x, 2x, and x times the square root of 3. Remember, if you can't get those labels in the right place, you absolutely will not get the right answer. In fact, you will get specifically all wrong answers. So just remember, the 2x always has to be across from the right angle. Okay? X has to be across from 30. Get those in the right place where my matchup is. X times the square root of 3 is equal to the side that says 14. Solve for x. Remember, I can't leave a radical in the denominator. Here goes my new skill again. This is rationalizing a denominator. In the top, I have 14 times the square root of 3. In the bottom, the square root of 3 times the square root of 3 is the square root of 9. I know what the square root of 9 is. That's just 3. I cannot reduce the 3 into this radical, nor can I reduce that 3 into the 14. So this is my best value of x. This is the simplest answer. So I know this is x. In order to find y, I'm going to have to double this. So be careful here. This is not easy. Take that value for x. If I want to double that, that means I want to multiply it by 2. If I write it as a fraction, that's 2 over 1. So the only thing I can do is multiply straight across. In the bottom, I have 1 times 3. In the top, the only thing I'm allowed, I can't multiply the 2 times the radical, but I can multiply the 2 times the 14. And it will not reduce, so there's my best value of y. Certainly the most difficult question for special right triangles. All right, here we go with trig. Here comes my calculator. It's calculator fun time. They want us to evaluate sine 54. They want me to round to the 4th decimal place. 4th decimal place is that second 0. Look to the number to the right. That number is 4 or lower, so I'm going to stick with 0.8090. Cosine 26. The 4th number is a 7. I look to the number to the right. It's a 9, so my 7 needs to go up 1. 0.8988. The 7 had to go up 1. Notice I did not have, when we round, we don't change any of the other numbers. Tangent 42. 0.9004. You will get answers different from me if you are not on the right setting with your calculator. If you're working through radians, you'll get wrong answers. Okay, so just try and remember, anytime we're trying to solve for the angle, we need to do the inverse. If we do an inverse, try and remember that switches the domain and the range. If those switch, now I'm doing the inverse of 0.3158, and my variable is over here. I just, in one fell swoop, I got my variable that I'm looking for all by itself. I just need to let the calculator do the work. Second sign brings up the inverse, and I just got to put in that fractional value. And it said round to the nearest 10th, which would be 18.4 degrees. We do it again, second cosine, 0.1271. To the nearest 10th, that would be the 6. Look to the right, my 6 has to go up to a 7. 82.7 degrees. All right. So here, this is not a special right triangle, so I'm going after trig. All right. So if I'm labeling the sides, this is my opposite side, my adjacent. The side not involved is the hypotenuse. So I need to remember my trig functions. All right. If I want to maybe rewrite this over here, sine is always opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I got O and A. This has got to be a tangent problem. Tangent of the angle has to equal the opposite side divided by the adjacent. If I'm missing the angle, I'm back to doing another inverse problem. So I'm going to do the inverse of tangent, and that's going to put my ratio inside the parentheses. So I'm just going to put in 17 divided by 15. And there's my angle measure. It says, now again, find the values to the nearest degree. That means whole number. This is 49 degrees because 48.5. The 8 is what I'm rounding to. Look to the number to the right. Let's play again. I have the opposite side. I have the hypotenuse. I don't have the adjacent, which means this has got to be a sine problem. Sine of b degrees has got to equal the opposite side divided by the hypotenuse. Again, missing the angle. Let's do the inverse. Rounding to the nearest degree, 67.8 means 68 degrees. All right, remember, in order to be doing trig, I need to do a right triangle. So don't be doing trig with the big triangle. I need to be doing trig with one of the triangles. So if both of these angles are the same, I can bring 20 over here. I can cut 38 in half, which means this side is 19. I'm forgetting about the other side. I need to be working this triangle. Bring in a different color to help my labels. This is my adjacent side. This is my hypotenuse. I'm not involving the opposite side, which means I need to be doing a cosine problem. Cosine of c degrees would equal the adjacent side divided by the hypotenuse. Doing another inverse problem, the inverse of cosine, put my ratio in there, and round to the nearest degree. 18.1 means 18 degrees. Okay, here, these next ones, it's very important. This is the most difficult part here is we've got a bunch of trig problems here. They've got descriptions, but we have no picture. We need a picture, okay? A seagull flying at an altitude of 500 meters. Here's my beautiful seagull that's at an altitude. Altitude means height of 500 meters. Find the angle of depression on Lake Travis to be, finds the angle of depression to a buoy. So there's some buoy. We gotta be careful. There's some buoy in the water here. But try and remember, an angle of depression needs to be, the seagull has its own horizontal perspective. The angle of depression is below a horizontal line. So my 60 degrees actually belongs here. It says find the diagonal distance from the seagull to the buoy. So I got 60 degrees there. I'll just make my right triangle over here. I'll move 500 over here. And then here comes my labeling again. I've got, and it turns out that's 60 degrees. Technically, this is a special right triangle. All right. Because that would be 60, this would be 90, and this would have to be 30 degrees. All right. So I'm going to go ahead and go special right triangles just so you can see this. If I labeled my sides, this would be x. The hypotenuse would be 2x, and this would be x times the square root of 3. All right. Now, they didn't say I had to put my answer in any sort of simplified radical form. So if I want to find x, I just have to divide the square root of 3 over to the other side. And so I can go 500 divided by the square root of 3 and get a decimal answer. Just beware, they want the diagonal distance, which is actually 2 times x. So just take that answer times 2. And since they didn't say I had to put it in simplest radical form, I'm going to go, and they didn't say what I had to round to, so I'm going to go ahead and choose my own rounding. I'm going to go with 577 about 577 meters. Okay. A glider leaves the cliff 1 kilometer high at an angle of depression of 4 degrees. So we're kind of doing the same thing. I got some glider up here. Looks like a triangle and some guy doing something crazy. But again, angle of depression. The glider is a horizontal perspective. The angle of depression is 4 degrees. And the cliff is 1 kilometer high. How far from the base of the cliff will a glider land? So I'm looking for this measurement here. I need this. So again, I can work in this triangle. I can either move the alternate interior angle here, or I got the degree already. X would be, this distance up here would be the same. And they want me to change it to meters. So instead of 1 kilometer, I'm going to go 1,000 meters. So again, trig, I'm going to label this as my opposite side. This is my adjacent side, and I'm not involving the hypotenuse. So if those are my labels, this means O and A means I'm doing a tangent problem. Tangent of 4 degrees would equal the opposite side over the adjacent. So if you listen to me in my class, the best way to solve this is go ahead and make it a proportion. Cross multiply. 1 times 1,000 is 1,000. And that's going to equal x times the tangent of 4. I don't want to grab my calculator until I have x by itself. Only way to get x by itself, I see multiplication, I'm going to use division. I'm going to try and keep it simple. Divide the tangent of 4, because remember the tangent of 4 is just some crazy number the calculator has memorized for me. If I got x by itself, that's my time to grab a calculator. So if I have the calculator, I'm just going to plug in what I read. What I'm reading there is 1,000 divided by the tangent of 4. Plug it in the calculator just like I read it. And there we go. So we're looking at, it says in meters, we're going to say this will be probably to the nearest meter. That would be 14,301 meters. Okay. Another tough drawing. When the sun is 5 degrees above the horizon is the horizontal distance that you see off in the distance. If the sun is 5 degrees above the horizon, the sun is up here. How long will it take the shadow of a 35-foot tree? So I got some tree shadows, in case you didn't know it, are actually on the ground. It says, how long will the shadow be for a 35-foot tree? The picture is everything. If you can't draw that picture, you cannot solve this problem. This is my opposite side. This is my adjacent. My hypotenuse is not involved. Opposite and adjacent means I can't be doing sine or cosine. I got to be doing tangent. It's the only one that involves O and A. Cosine needs A and H. Sine needs O and H. So it should be a definitive decision on what trig function I'm using. The opposite side is 35. The adjacent side is x. And here we go. Solve it like a proportion. That's just my recommendation. 1 times 35 is 35. X times the tangent of 5. Again, I want x by itself. Move that tangent to the other side if I have to. If I've got x by itself, it's calculator party time. And it doesn't tell me what to round to, so I'm going to go just right about 400 feet. And then it says when the sun's angle of elevation. Again, I'm doing the same kind of sun problem. The sun Angle of elevation is 31 degrees. My friend Jason has so Jason's standing somewhere. Jason's got a shadow of 10 feet. How tall is Jason? There's my problem. Opposite, adjacent. We sure are doing a lot of tangent problems here. The tangent of 31 degrees equals the opposite side over the adjacent. I go solve this one. This one's a little bit easier. 1 times x is x, and then I have 10 times the tangent of 31. When the variable's on the top of the fraction, the variable's going to isolate itself on the very first step, which is nice. Then I just got to put in what I read. 10 times tangent of 31. X equals about 6 feet. When the sun's angle of elevation has increased by 10 degrees, my shadow is 6'2". How tall am I? So that the degree measure increases to 41 degrees, the shadow becomes 6'2", but I don't want feet and inches, so I'm going to go all inches. So 6 feet times 12 is 72. Add the 2 more inches, 6 feet and 2 inches means I'm at 74 inches for my shadow. So I'm just going to replace the numbers. I'm still doing a tangent problem, but my angle is now 41 degrees, and my shadow is now 74 inches, which means I got x over 74, and I'm doing the same idea. I'm going to cross multiply. X times 1 is x, and 74 times the tangent of 41. Calculator party time. Oops, don't want to do 2 tangents. So again, this is inches. So we're looking at approximately 64 inches. So this person's shorter. They're 5'4". But they didn't ask they didn't mandate what units. I'm going to go ahead and stop. I'm 64 inches tall. One more page. All right. State if the triangle is acute, obtuse, or right. Remember, this is going to come down to the Pythagorean theorem. If a squared plus b squared equals c squared, that is by definition a right triangle. If a squared plus b, and we want to focus on c squared. If c squared ends up being bigger, then it's going to be an obtuse triangle. If c squared ends up being smaller than a squared plus b squared, then it's acute. Okay, so we just need to grab our calculator. What's 9 squared plus 12 squared? And I know which ones are A and B because C has to be the biggest one. So I want to find out what that is, and I'm going to compare it to C squared. They're not equal, so it's not right. C squared is bigger. This kid is obtuse. This is the only game we got to play. All right, c squared's got to be the 15. That's 225. I'm going to compare that to 9 squared plus 9 squared. C squared's bigger again. I got another obtuse triangle. I know it's not drawn that way. That's intentional. You can't go by looks. All right, you got to go by what you can prove. 2 more to go. 6, 8, 10. I already know the answer. This is a classic one. 6 squared plus 8 squared is 100, and I know 10 squared is also 100. That means this is a right triangle. Pythagorean theorem worked. 9 squared plus 12 squared is 225. I know 17 squared is bigger than that. So c squared is bigger. This is another obtuse triangle. And this last question, would sides 4, 4, and 8 make a triangle? So the triangle, one of the triangle inequality theorems says, remember, the 2 smaller sides must add up to be bigger than the third. So if our third side was 8, and I tried to make a triangle with a measure of 4 and 4, we would not be able to enclose any space. It would just be a linear situation. We need the sum of the two smaller sides to be bigger than the third to actually make a triangle. All right? So I would say no. Two sides. And really, I could put it in the word, any two sides must always sum to be larger than the third. If we state it this way, it doesn't matter about whether things are small, because I could have sides 5, 5, and 5. We don't want to talk about which ones are the smallest one. Any two sides must add to be bigger than the third. Can I make a triangle here? Yeah. 5 plus 5 is going to be bigger than 5. All right. But we can't with 4, 4, and 8. 4 plus 4 is not bigger than 8. We can't with 1, 2, and 3. 1 plus 2 is not bigger than 3. Okay. All right. That is the review. Hopefully that makes sense. If not, contact your fantastic teacher, Coach Foss. Get your questions answered. Be ready for the test. Goodbye and good luck.